What is statistics? Statistics is all about data. It is the science of collecting, organizing, analyzing, and interpreting data. Statistics are everywhere in our day-to-day life, from scoring averages in sports to political polls. It's even in weather prediction probabilities. There are two main branches of statistics: descriptive statistics and inferential statistics. How are they different? Let's say you have 25 friends, and you want to know their daily social media usage, but you didn't have enough time to get all their data. So you got the data of just the 5 of them. Here, we have a set of numbers that show the daily social media usage by those 5 friends of yours. Let's consider this as our sample data. We can see that the most common number in this data set is 5. This is an example of descriptive statistics. It describes a sample. Inferential statistics, on the other hand, uses the sample data to make inferences or conclusions about a larger population. So if you want to figure out what % of your 25 friends spend more than 5 hours on social media every day, you use inferential statistics. You may already be familiar with some of the common tools of descriptive statistics. They are the measures of central tendency and the measures of dispersion or spread. The measures of central tendency tell us where most values fall, or the typical value of a dataset. Going back to our sample dataset, let's find the 3 most common measures of central tendencies. Let's begin with the mode. This is the value that shows up the most number of times in a dataset. We've seen this earlier in our example of descriptive statistics. Next is the mean, often called the average. This is one of the most common ways of summarizing data. It's simply the sum of all the numbers divided by the number of elements. Another measure of the center is the median. The median literally looks for the middle number. To get the median, we need to sort the dataset first, then pick out the middle number. Although measures of central tendency provide some clarity on a dataset, they don't tell the whole story. Another tool to describe data is through measures of dispersion. To easily understand the measures of dispersion, let's compare our earlier sample with this new dataset. Although both datasets have the same central tendencies, the data points in set A seem to be close together, while the data points in set B are farther apart. To get a clear picture of how spread out the data points are in both datasets, let's get their range, variance, and standard deviation. These 3 are the common measures of dispersion. To get the range, let's take the largest number and subtract the smallest number. Getting the variance and standard deviation may seem a little complicated. We need to use all these formulas after all. But don't worry, if you use Python, you won't need to memorize these formulas. Now we have here the measures of dispersion for our 2 datasets. Variance tells us the degree of spread in a dataset. The more spread out the data is, the larger the variance is in relation to the mean. Standard deviation gives information about the spread of data values from the mean value. If the standard deviation is small, the data values are close to the mean value. If it is high, the data values are widely spread out from the mean value. Now let's use a simple number line and plot our measures of dispersion. We can easily see that the data points in dataset A are clumped together near the mean, while in set B, they are far from the mean. And that's all for this video. In this video, we discussed descriptive and inferential statistics and the common measures of central tendencies and dispersion. Now that you have a good grasp of the basics of statistics, let's get ready to learn more about statistics with Python.